Now, you've been hearing of differential equation, differential equation. How are they formed? How are they formed? So, we have a classical example here that says y equals a sine x plus b cos x. So the first thing we are going to do is to step one. The first thing is we try to see if we can differentiate y. So you say, let's find the y, the x. Differentiation of y, differentiating y with respect to x. Let me repeat that again. Differentiating y with respect to x. So what you're going to have here is a cos x plus or minus. First of all, you can do it this way, plus. And let's differentiate cos. Remember, if you differentiate sine x, you have cos x. If you differentiate cos x, you have minus sine x. Is that not? Okay. So if you differentiate cos x here, you're going to have a negative sine x. And then you multiply it by b. So you have b minus sine x. Is that correct? So what we have is the y, the x, is equal to a cos x minus, this is that, minus b sine x. A cos x minus b sine x. Now, there is no relationship between y and the y dx. Let me repeat that. There is no relationship between y and the y dx. So all we need to do now is to find the second order, the squared y over the x squared. So what will happen if we find the squared y over the x squared? You now discover that at this junction we're going to be having a minus a sine of x minus b cos of x, because the differential of a cos is a negative sign. And so when you multiply a negative sign by a, you're going to be having a negative a sine x minus b. If you differentiate cos sine, you're going to have cos. So the squared y over the x squared will be minus a sine x minus b cos x. Now, notice that now we are treating formation of ODE. How are ODEs formed? How are ordinary differential equations formed? Notice that there is a relationship between y and the squared y over the x squared. Have you noticed? What's the relationship? The relationship is that this person, when multiplied through by minus, will give you this. Let me repeat that again. If you multiply through, let's assume that you multiply the squared y over the x squared by a minus. You're going to have this back. So, if the relationship has been set, it means that the squared y over the x squared is equal to a negative of y. Is that not? The squared y over the x squared is equal to a negative of y. Did you understand me now? So, now, what can you do to that function to make it a differential equation completely? You can now say that the squared y over the x squared plus y should be equal to 0. Now, this is a differential equation. This is a differential equation. I hope that's clear now. So, you can see how I built it from here and I made it look like this. Some textbook are going to explain to you and say y prime prime plus y should be equal to 0. That's also a differential equation. I hope you can see that. So, this is self-explanatory. If you go through the step from here, you'll be able to get this. Because when you say the squared y over the x squared, what you simply mean is second derivative, right? Y prime prime plus y equals 0. I hope that is clear. Alright.